we go on to the next part. So make sure you've got your formula sheets out and you can see your electrochemical series. Because this is just a reminder of what we've already talked about. For a spontaneous redox reaction to occur, we need to react a stronger oxidizer with a stronger reducer. That means that we're going to have a diagonal relationship between them. It doesn't have to be a big diagonal, and although we could assume that the gold 3+ ion is going to react very rapidly with magnesium, for example, we can't assume that this will give us an indication of the rate. But some of these will be very vigorous reactions. They will all occur spontaneously, meaning that they don't need any additional assistance, that this reaction will just take place by itself. They don't have to be a long way apart, like even if they're just one above the other on this table, that spontaneous reaction will still occur. So for example, the nickel 2+ ion will still readily react with cobalt metal. Okay, we don't need to have a big difference between them. But also, the cobalt ion, 2+ ion, will not react with nickel. The chromium 3+ ion will not react with copper. Okay, so anything in that other orientation will not react spontaneously. So they're our basic rule of thumb for using the formula sheet, the electrochemical series on your formula sheet. We are not going to worry about this column still, but we will start looking at that in our next booklet. But if you have a look on page 24, we've got an example. And I don't know if I'm allowed to write on the TV screen. It's tempting. Only if I have it as a PowerPoint. Yeah, but that's something I could do, is maybe save one of these so that I can write it on my laptop. But if you find the mercury, can you see mercury on here? We've got our mercury half equation up here. Then we've got copper, and it's, what's it, 1, 2, 3, 4, 5 below the mercury. And then we've got zinc, which is what right down here. So can you find those 3 half equations on your formula sheet, please? Just maybe make a pencil mark next to them. Now it tells me the strongest of the 3 oxidizers listed is mercury 2+. That makes sense, doesn't it? Because there's the mercury 2+. If I look at the arrow of my strength of oxidizers, the mercury 2+ is higher than the copper 2+, which is again higher than the zinc 2+. Yep, so that's the strongest oxidizer in my list. And the zinc is the strongest reducer. Yep, because if this way the arrow is pointing down, and so the zinc is the strongest reducer, then the copper is middle, and the mercury is the weakest of the 3. So part A, what does that mean? That means that the mercury ion will react spontaneously with any reducing agent that is a stronger reducer than mercury. It just has to be stronger than mercury, and then it will spontaneously react. So in our list, the copper and the zinc are both stronger reducers than mercury, and therefore a spontaneous reaction will occur. If we look at the copper ion, Cu2+ ion, again, it is only going to spontaneously react with a reducer that is stronger than copper mercury, which means it will spontaneously react with the zinc but there'll be no reaction with the mercury because the mercury is a weaker reducer than copper. Okay? And then for our zinc 2+ ion, there will be no reaction with either metal because the copper and the mercury are both weaker reducers than zinc. So we need to look at all of the information given about a particular metal-ion combination. We only want to compare reducers with reducers and oxidizers with oxidizers. Okay? So we've now gone through all of our oxidizers. But if we look at this same set of reagents now from the reducer point of view, for the mercury metal, the only ions that are present in our series are the mercury ions, the copper ions, and the zinc ions. And there will be no reaction for the mercury because the only ions present are weaker oxidizers than mercury 2+. Does that make sense? That these are weaker and therefore there's no reaction. We know they've got to be strong for our reaction to occur. For the copper metal, we're looking to see, well, how do our oxidizer strength compare to the copper 2+ ion? Well, the mercury 2+ ion is a stronger oxidizer and therefore a spontaneous reaction will occur with the copper. But the zinc 2+ ion is a much weaker oxidizer than the Cu 2+ ion, so there's no spontaneous reaction with the zinc ions. And for the zinc metal, the mercury ion is a much stronger oxidizer than the zinc 2+ ion, therefore a spontaneous reaction will occur. The copper 2+ ion is also a stronger oxidizer than the zinc 2+ ion, and so a reaction will occur there as well. Does that make sense? So every time we're looking at a reducer, we are comparing with other reducers, and when we're looking at oxidizers, we can compare with other oxidizers. We need to have a stronger oxidizer reacting with a stronger reducer for a spontaneous redox reaction to occur. Okay. So now we've got another page of questions.